Hello to all the lovely cloud enthusiasts and welcome to my channel The Cloud Minds. How are you all doing? I hope that you all are doing great physically, mentally, financially, and I hope that you're taking steps to become a better version of yourself than you were yesterday so that your future self can thank you for the steps that you've taken today. Guys, many of you have already been following me. I'm really grateful. I'm really thankful to you all. And for those of you who are new, let me give you a quick introduction about myself. My name is Tejas Mahendrakar. And on LinkedIn, if you type Tejas Mahendrakar in the search box, you will land on my page. And if you want, you can connect with me. I'll really be happy to connect with you all. The Cloud Minds is the name of my channel on YouTube. And statistics show that 80 to 85% of you who are watching these videos are not subscribed to the channel. I would really be happy if you can subscribe to the channel. You know, if I get some more views, some more subscribers, I'll really be happy, and that will give me motivation to create more of such videos. The third but not the least is my email address. thecloudsimplifier@gmail.com is my email address. If you're stuck somewhere, if you're requiring any technical assistance, or there is something that you want to share with me, I'll really be happy to connect with you to resolve your queries, be it architecturally, be it technically, or be it personally. I'll really be happy to connect with you all. All right. So guys, today's topic, it's very interesting actually, because whenever I find a topic interesting, I think of making videos and then sharing it with you all, so that you also can get a little bit of understanding of how this entire architecture or how this entire AWS or the cloud technology works. Today we're going to look at something called as a visual map of VPC. Now, if you think about VPC, it has a lot of components. It has something called a subnets. You all must be knowing, because I've already made videos previously wherein I've explained what is VPC, what are subnets, how do you create the CIDR blocks, etc. So I've created the videos previously. If you want, you can take a look at it. I'll also provide the link in the description box. Secondly, the VPC, as I said, contains a lot of components such as subnets, such as route tables, such as NAT gateway, such as internet gateway, and all of this can be confusing and overwhelming to a person who is just starting to learn. That's the reason why I decided to make this video where we can actually visualize how the data is flowing from the subnet till the internet through either the internet gateway or the NAT gateway, and how does the data come back to your subnet or to the instances of the services that are within your subnet. All right. So now today what are we going to do is, I have actually written a quick summary, a very brief summary of course, of what we are going to do. We are going to create VPCs today. VPC, because we already have default VPC, we're going to create one more VPC. We'll create two subnets, one is private and one is public subnet. Of course, we can create more than one private and one public subnet, but I'll just create two of them. One is public subnet, one is private subnet, and I'll try to put them in different VPCs for fault tolerance purposes. Right? And the next thing that we'll create is NAT gateway and internet gateway. Those are the two things we need to create. And if you all know already, we will require ENI or the Elastic Network Interface or a public IP address attached to the NAT gateway. And don't worry, if you do not know it, we'll be looking at it. We'll be looking at all of these things. Last but not the least is the route table. Now this is very important but confusing part for many of us. Why I say it's confusing? Because you have to exactly match the route table with the subnets and the internet gateway or the NAT gateway so that the traffic properly flows. But to create all of them in your head, it becomes quite overwhelming. Let me be very honest, because initially when I started my AWS journey, it was really difficult for me to visualize everything, how the data flows and how it goes back out to the internet, comes back within the subnet, or within that instance that is available within the subnet, or any other services that are available within the subnet. These are all confusing and overwhelming part. That's the reason why I thought I'll make this video and make it easier for you guys to understand. Without further ado, let's go ahead and understand how do we create this visual map of the AWS or AWS VPC. Now, whenever you log in, this is the first login page of AWS, that is the AWS Management Console. We already know about it. And this is the VPC dashboard. When you visit VPC dashboard, it looks something like this. You can very well see how many VPCs you have, how many NAT gateways you have, what are the subnets, what are the NACLs, what are the route tables, etc. You get all of the detailed view here on the VPC dashboard. But let's start with creating a VPC, because that is the first step that I've provided here. Right? So let's go ahead and create a VPC. It's quite simple. I have already explained this to you. If you want, you can all take a look, or if you want, you can skip to the part where we start looking at how do we create the subnets. All right. Let me create a demo VPC which has visual touch to it. That's the reason why I've added visual to it. All right. Now I want it as IPv4. I'm okay with it. I'll just create my favorite IPv4 CIDR range, which is this, and I'll create 18. Now I have already explained you what is this, what does this /18 mean, and how do we perform calculations in one of my previous videos, for which I'll provide the link in the description box. The tenancy I'll leave it default, and then I'll not change anything with the tag as well. I'll create the VPC. Now once I create the VPC, I can go ahead and I can see the demo VPC visual here, and if I scroll down, it will show me something called as a resource map, which is not yet properly connected right now. That's because I haven't yet created the subnets, I haven't yet created the route tables, and I have not joined the subnets to the route tables to the internet gateway or the NAT gateway. I have not yet done the association for that. That's the reason why it shows very distinct or very detached part of components. Let's go ahead and create subnets. What I'll do is I'll create two subnets. One is private subnet and one is public subnet. Now, for creating the subnets, of course, I'll have to select the VPC in which the subnet will be created. I'll create this and I'll call this a public subnet. All right. Now, what will I do? Like I said, I'll create this in different availability zones. I'll create this in AP South 1A, and the other one I'll create in AP South 1B. Now, here is very important part. If I give 10.0.0.0 / if I want less number of IP addresses, I can just get 1000 IP addresses, or if I want less IP addresses, I can just increase the number. By increasing the number, we are reducing the number of IP addresses. That's how this works. Let me go ahead and actually count 23. Let's keep it 512 IP addresses. Of course, we'll not be needing all of those, but just for demonstration purposes, let's keep it at 512. I'll create another subnet, and here I will call it as a private subnet. I will select this as a different availability zone, and here I'll do the same 10.0.0.0/23. This will show me 512 IP addresses. Now if I go ahead and create the subnet, it will throw an error that the IP addresses are overlapping with each other, because if you see, it's 10.0.0.0/23, and here also I have the same IP address range. That is the reason why it says that overlapping IP addresses is not allowed for the subnets, which is logical as well. What I need to do is, I do not have to calculate and create the number of IP addresses that are 512 ahead of this IP address range. I just can use this functionality here, and then VPC or the AWS automatically allocates the next set of CIDR range files. Alright, so what I'll do, I'll go ahead and create the subnet. Now if there are any issues, it will show that this subnet was created with the issues, but there are no issues, so it has created the subnets very well. Now we have seen that the CIDR ranges are /23/23 for both, and it is 10.0.2.0 and 10.0.0.0. These are private IP addresses, mind you. Alright, now how do we make public and private subnets? Not just by naming them private and public, but by attaching internet gateway and attaching NAT gateway to them, and providing the specific route in the route tables. Alright, now let's just look at the available IP addresses, because there are 507 available IP addresses, it says, because 5 IP addresses, like we have already discussed, are reserved by Amazon or the AWS. As we know, I have created it in availability zone 1B and availability zone 1A, and rest everything remains by default. This is the VPC to which both of the subnets are attached. Now let's go ahead and create route tables. Now here is an interesting part where we have, in my previous demonstration to my students, I've already shown how do we create route tables. Here also I'll go ahead and create the route tables and then show you how do we create the route tables. This is a public route table. Now why do I have to specify public and private? Because the public subnets have to route through the public route table to the internet gateway, and then the private subnets have to route through private route table to the NAT gateway. All right. So they are two different things. We'll try to understand those as well. As we move ahead, we'll try to understand what are NAT gateway and what is an internet gateway as well. I need to select which VPC I need to put this in. I'll put this in demo VPC visual, which is the visual mind map that we are trying to create. All right, I'll create the route table. Now let me copy the name of this particular route table, and I'll create another route table which is a private route table, like I told you. Right. So let's create another private route table, and I'll put it in the same VPC and create the route table. Now, interesting part, let us go back to VPC and then try to visualize how this actually looks. Now, if you see, I've created two subnets, and both of the subnets, mind you, are routed to a default route table that is created when I created this subnets. So there was a default route table that was created within the subnet. When I created the subnets, a default route table was created. Both of the subnets are actually attached to the route table, the default route table, which is RTP. It starts with 06 and it ends with 2D. We have not configured or created any internet gateway or NAT table, NAT gateways. That's the reason why you are not able to see anything here. Let's go ahead and look at what is the summary that we have done. Now we have created the VPCs. We have created the, it's not don't, it's actually done, right? We have created the subnets, which is the public and private subnet. We have to create the NAT gateway and the internet gateway. We have created the route tables, public and private route tables, and this is partially done. Why do I say partially done? Because there is more configuration that has to be done for the route tables, so that the data from the subnets can move out to the internet, and the data from internet can come back to the subnet through the route tables. All right. Now let's go ahead and look at creating internet gateway. Now, if you visit here, I've already created internet gateway. Let me create another internet gateway. This is demo visual VPC internet gateway. Okay. There's nothing that we need to create. It's just how the traffic is routed out. So I've created a demo visual VPC internet gateway. Similarly, we also need to create something called as a NAT gateway. The difference between NAT gateway and internet gateway is NAT stands for network address translation. What it does is it converts or it translates the private IP addresses from the private subnets to its own IP address, and then it sends out to receive the traffic. Once the updates or any traffic that is received back, it can only communicate to the NAT gateway, and then the NAT gateway converts it back and then sends the traffic, redirects or routes the traffic back to the private subnet. Now the way it works is, as I said, private subnets will have private route table which is actually connected to the NAT gateway. It is not connected to the internet gateway. So there is no outbound connection that goes to your specific subnets that is private. Now why do we require this? Now imagine that we have a 3-tier architecture wherein I have the presentation layer, there is a logic layer, and there is a data layer. The presentation layer, of course, has to be in the public subnet, whereas the logic and the data layer has to be in private subnet. Why? Because we do not want anybody outside of this AWS to be accessing the resources that I have put in my private subnet. And that is the reason why we need or we use NAT gateway instead of the internet gateway. I hope this is clear. I know it is slightly confusing. If it is confusing, you can scroll back the cursor and then you can look at this part again so that it gets into your head on how this actually works. Let me reiterate. Private subnets will route through private route table to the NAT gateway. Public subnets will route through public subnet to the internet gateway. Now, let's connect NAT gateway to it. There are two things actually we need to be very careful of when we are creating the NAT gateway. First is that it always goes into public subnet. Why? Because public subnet has the internet access and NAT gateway requires internet access. Of course, it can still talk to the private subnet via the private route table. Okay. Now let me go ahead and create something similar. Now this is not a route table. Let me create a NAT here, which doesn't have to be public or private. I'm creating a demo NAT, which is a NAT gateway. Of course, I have to, like I said, I have to put it in the public subnet. And The one that we have created for public is demo subnet visual VPC public, and I'm going to put it in the public, and I need to allocate an elastic IP like I said. When I click on that, it automatically allocates an elastic IP. Now why do we need it? Because as I said, the subnets that are the instances that are in private subnet will connect to the NAT gateway, and then the network address translation happens there, and that address is when NAT has to talk out to the internet, or there are some updates or patches that are required from the internet and NAT gateway has to talk to the internet, it will require an elastic IP. I know guys, this is, like I said, it is confusing, but if you look at this video 2 to 3 times, I am definitely sure it will be very clear to you. Alright, I'll try to make it more clearer by looking at the visual map. Let me just create the NAT gateway as well. I have allocated, like I said, the elastic IP, and I have put this NAT gateway in the public subnet. Do not get confused, NAT gateway connects to the private subnet, but it is placed in a public subnet. Now let us go back to the VPC and try to understand or try to visualize how this all looks. If I click on my VPC and then I click on the demo visual VPC, I can see that the route map is starting to take shape. You see that there is one demo visual NAT VPC. Why it is not showing there? I do have to attach the NAT internet gateway to a VPC. That's the reason why it was not showing there. I forgot to attach it to internet gateway, and this is very important steps that we need to attach it to a VPC. The internet gateway has to be attached to a VPC. Now if I click on this and I look at it here, I see that the demo visual VPC internet gateway and demo NAT visual VPC are both the NAT gateway as well as the internet gateway have been created. However, they still do not have the route out to the NAT gateway. Okay, now let's head back to route table and create some magic, after which we'll be able to see how this all links together. Let me actually open the VPC console here so that we can just refresh and look at the resource map, how it keeps on changing. Okay, now let me go to the route tables. This is a route table that I have created. This is the public route table. Now to public route table, there are 2 things that I need to do. I need to attach internet gateway and I need to attach public subnet. That's what I'm going to do. I'm going to click on subnet association here. I'll click on edit subnet association, and then I'll only select the public subnet, and then I'll say save association. After I do this, if I come back and then if I refresh this, let me just actually refresh the page itself. If I actually refresh this resource map, you can see that there is something that has changed. If you see that the public demo subnet is actually attached to the demo route table. Let me go back and create more associations. For the public VPC, what I need to do is I need to go to routes, I need to click on edit routes, and then I need to add a route out to the internet gateway. Yes, so here I need to select internet, which is 0.0.0.0/0. That's the IP address or the CIDR block for the internet, and here I have to select the internet gateway, and it will show the options that we have created previously, and I have to save the changes. Now this public route table, let me be very specific, this particular public route table now has an internet gateway and now has a subnet association, which is the public subnet. Now if I refresh this page, let me actually refresh the page itself. Now if I refresh this page, you will see that the association has already taken place, and then there is a route out from the subnet to the route table to the network connection, which is the internet gateway. If you click on it, it will show how this actually flows. This is a very beautiful visualization that VPC or the AWS has provided us. Alright, so similarly, what are we going to do? We are going to do the same thing for private as well. It will be very quick because I've already shown how to do it. So I'll go to the private gateway, I'll look at the edits, routes, I'll click on the routes, I'll select everything from the internet, but this time I'll select the NAT gateway and not the internet gateway because this is a private route table. I'll save the changes, and then I'll come here in below in a subnet association. I'll edit the association and I'll only add the private subnet to this. Alright, now we know that we have 2 route tables. One is a public route table, one is a private route table. The public route table has public subnet and private route table has private subnet. Now if you come back to this VPC and then you refresh the page. Now this is where the magic happens, and this is very beautifully visualized here for us. If you click on the demo private subnet, it will show you how the route out to the internet is. If you see, the route association to the default route table has been taken out, and the association has been created from the NAT to the route table, the private route table, and to the private VPCs, private subnets, and the public subnet has a route out through the public route table and out to the internet gateway. This is very beautifully created, and this is very beautiful to visualize how all of this builds together. That is what I wanted to show you guys. That is what the actual route map shows when you actually attach all of these together. So what we have done is, let's go back and understand our summary. Let's call this done. Let's call this done as well. What we have done is, we have first created the VPC. I'm reiterating what we have done. We have created two subnets. One is public subnet and one is private subnet. I've created a NAT and internet gateway separately, and then I've created public route table and private route table. For the public route table, I have put public subnet and the internet gateway. For private route table, I have put the private subnet and the NAT gateway. That is how the association is. Now, if you want to try and connect to the instances, create an instance both in public and private subnet and try to connect to the instances. You won't be able to go through the instances that are in private subnet. Why? Because of the NAT gateway. It will not even allow you to SSH unless you SSH using PuTTY or some kind of bastion host that is in the public subnet. Alright guys, this is what I wanted to show you, and I'm really thankful, really glad that you decided to stay till the end to understand the nitty-gritties of how all of these route tables and subnets and internet gateway and NAT gateway work together, and I'm really happy that I am able to add some value to you guys. Alright, that's what I wanted to tell you guys. That's what I wanted to show you, how all of this fits together. And if you have any doubts, I'm always available on the email. Just shoot me an email and I'll be really happy to help you at any technical point. Alright guys, this is Tejas signing off, and you all have a great day.